Look up at the night sky. It seems peaceful, but just above us, an invisible storm rages. A cloud of human-made objects, space junk, circles Earth at incredible speeds. This isn't just a few lost items. It's a growing swarm of discarded rocket stages, dead satellites, and countless fragments from past collisions. Each piece, no matter how small, is a bullet in the cosmic shooting gallery. This silent storm threatens our future in ways we're only beginning to understand. For decades, every mission has left behind debris, from bus-sized rocket bodies to flecks of paint. In space, these objects don't slow down. They keep going, faster than any bullet on Earth. Imagine a tiny screw, lost decades ago, now traveling at over 17,500 miles per hour. At that speed, even a speck can shatter a solar panel or puncture a spacecraft. The real danger isn't just the big pieces we can track, but the millions of smaller, untraceable fragments. The sky above is not as empty as it appears. It's becoming a junkyard. This growing cloud of debris is a testament to our ambition and our short-sightedness. It encircles our world like a silent, swirling storm that could one day cut us off from the cosmos. We've filled the heavens with our dreams and our trash. The time has come to face the consequences and find a way to clean up the storm. Our journey to the stars began with Sputnik in 1957, a triumph, but also the start of our orbital debris legacy. The rocket that carried Sputnik became space junk, and every launch since has left something behind. Rockets shed stages as they climb, leaving large, dangerous debris in orbit. Satellites, designed with limited lifespans, become uncontrollable ghosts when they die. Over 60 years, this cycle has created a cluttered, orbital environment. The danger isn't just from large objects. Collisions shatter them into thousands of fragments. Each fragment becomes another projectile, multiplying the problem. Even a fleck of paint can chip a space station window. A marble-sized piece can destroy a satellite. We've created a minefield in the sky. This legacy is written in metal fragments, spent boosters, and dead satellites. Space is a finite resource, not an infinite dumping ground. For too long, we ignored the consequences. Now the evidence of our past actions circles above us, a constant reminder. Our journey into the future requires us to clean up the mistakes of our past. The space around our planet is precious. It's time to treat it that way. There's a tipping point in orbital debris, the Kessler Syndrome. Proposed by NASA scientist Donald Kessler in 1978, it describes a future where space junk density triggers a chain reaction of collisions. One collision creates more debris, which causes more collisions, a cascade that feeds on itself. Imagine cosmic billiards. Every impact shatters objects into thousands of fragments, filling the sky with hazards. If this begins, it could render orbits unusable for generations. Launching new spacecraft would be like playing Russian roulette. We'd be trapped on Earth, cut off from the cosmos by our own trash. This isn't science fiction. Many scientists believe we're nearing this tipping point. The number of objects in orbit is growing, and so is the risk. We must act before this chain reaction truly begins. The threat of space junk is real and happening now. The International Space Station, our outpost in space, is under constant threat from debris. The ISS must perform emergency maneuvers several times a year to dodge incoming junk. Astronauts have even sheltered in escape capsules, ready for evacuation. In 2009, a defunct Russian satellite collided with an active US satellite, creating thousands of new debris pieces. In 2007, China's anti-satellite test created one of the largest debris clouds in history. These events show the danger is real and growing. The sky is not just full of stars, it's full of bullets, and we're flying through them. Each collision adds to the problem, threatening satellites and astronauts alike. The consequences are severe, and the problem is getting worse every year. The good news? We have the ingenuity to solve this problem. Around the world, scientists are developing technologies to clean up our cosmic backyard. One idea: launch a spacecraft to capture debris with a net or harpoon, then drag it into the atmosphere to burn up. The European Space Agency's Clear Space 1 mission will test this approach. Other concepts include using lasers to nudge debris or magnets to grab metallic junk. Capturing tumbling objects at high speed is difficult and expensive, but progress is being made. Legal and political questions remain. Who is responsible and who pays? Despite the challenges, we're moving from tracking the problem to actively solving it. The cosmic cleanup crew is getting ready for work. The future of space depends on their success. What if we fail? If the Kessler Syndrome becomes reality, we could be trapped on Earth, cut off from space. Satellites are the invisible backbone of our civilization, guiding us, connecting us, protecting us. Without them, GPS, weather forecasts, communications, and global finance would collapse. We'd be thrown back into a pre-digital age. Satellites also monitor climate change, disasters, and provide national security. Losing them would make the world more dangerous and blind us to global threats. Space exploration inspires us and drives innovation. To be confined by our own garbage would be a tragic, self-inflicted wound. The dream of reaching the stars would end, not by nature, but by our own neglect. The consequences would affect every aspect of modern life. The story of space junk is a cautionary tale, but it's not over. We created this problem, and we can solve it. The same ingenuity that took us to the moon can clean up our orbit. We must remove dangerous debris and stop making the problem worse. International cooperation is essential. Space is a shared resource. Future satellites must be designed for responsible disposal. Every new launch should be part of the solution. We stand at a crossroads. One path leads to a sky filled with wreckage, the other to a sustainable future in space. The choice